Hey kiddos, today we are going to be talking about parallel lines and transversals. All right, so let's go over some vocabulary. We have something called corresponding angle theorem. So if two parallel lines are cut by a transversal, so notice here in this picture, line P and line Q are the parallel lines, and I can see that by the symbol here. Okay, so therefore line T is cutting through both of those lines that are parallel, so that line is called a transversal, right? So if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So meaning that in this case, angle 2 is in the same spot as angle 6, so they're going to be congruent. And I'm just going to put this marking here. So also angles 3 would be congruent to angle 7 because those are also corresponding. And notice we have plenty more corresponding angles. Angle 1, angle 5, and angle 4, and angle 8. Okay, so essentially what we're saying is that they would actually be congruent in their measurements. All right, so next we have the alternate interior angles. Remember, really focused on what does it mean when we say alternate and interior. So if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So for example, angle 3 and angle 6, notice they're alternate. They're on different sides of the transversal, okay? But they're interior because they're inside of the parallel lines. So that makes them alternate interior. And because of that, then we would say that they are, in fact, congruent. So angle 3 would be congruent to angle 6. And the other pair of angles would be angle 4 and angle 5. They're also alternate interior, so they would also then be congruent to one another. Next, you have alternate exterior. Okay, so alternate still applies, meaning are on different sides of the transversal, but this time we're going exterior, which means we're going on the outside of the parallel lines. So we have angle 1 would be congruent to angle 8, and we would have angle 2 congruent to angle 7. Next, we have consecutive. Remember, consecutive can also be same side interior angles. So same side interior angles. So interior, again, interior means inside of the parallel lines. Consecutive means the same side of the transversal. So we're looking at 3 and 5. Now, these are not congruent. And this is kind of why I like using the word same side instead of consecutive. Because same side starts with the letter S, as does supplementary, okay? So when you have a situation where you have consecutive interior angles, okay, they are supplementary to each other, which hopefully you guys recall means that it adds up to 180 degrees. All right, so consecutive angles are going to add up to 180 degrees. They're not congruent. They're going to be supplementary, okay? So you can think of, if you remember consecutive and you remember same side, that's kind of a way, or you can trigger your mind to remember that it's supplementary. They add up to 180. So in the example here, it would be angles 3 and 5 would be supplementary to one another, along with angles 4 and angle 6 also being supplementary to one another. I don't want us to forget about consecutive exterior angles, so you may want to write this in. But consecutive exterior angles, okay, would also then be, remember, consecutive stands for same side, meaning that they are going to be adding up to 180 degrees. So in this visual that I'm giving you, angle 1 and angle 6 are same side or consecutive exterior because they're outside the parallel lines, and they would also be supplementary, which means they'd add up to 180. All right, find the angle measures. State the theorem that you use to find each angle. So, angle 2. So we're looking for angle 2 based off of knowing that this angle here is 120 degrees. So how can we figure out what angle 2 is? Well, hopefully you are seeing that it's a linear pair. And if it's a linear pair, then we know that it is going to add up to 180 degrees because linear pairs are supplementary. So that would lead that angle 2 has to be 60 degrees. 180 minus 120 gave me that 60 degrees. All right, so angle 2 is 60 degrees. Whoa, I did not mean to do that. I meant to write 60 degrees. Okay, now let's look for angle 3. Angle 3, well, there's a few different options you have to find the answer, and I'm going to use linear pair. So therefore, if I'm using the linear pair theorem, then that means that I'm looking at them to be supplementary, which means they would add up to 180. So angle 3 would also be 60 degrees. Hopefully you guys are seeing different options though. I didn't have to go linear pair. I could have actually gone vertical angles right here because we also know that vertical angles are congruent. Okay, so notice you always have a lot of options, so just keep that in mind. Angle 4. How can we find angle 4? Same concept. We got a few different ways that we can figure out what angle 4 is. Okay, you can use the linear pair, or we could even use vertical angles. It just depends on what you see because everyone sees something different. So in this case, I'm going with vertical angles here because I personally think that's the easiest one to find. Okay, those are the easiest ones to identify because they share that vertex and they're located diagonally across from one another. So in this case, angle 4 then would be 120 degrees. All right, now let's look for angle 5. Now, to find angle 5, I have to use something from over here to help me figure out what this is. All right, so I'm going to go with corresponding angles. Now, corresponding angles means that I'm looking for an angle then that's in the same location as angle 5. The same spot as angle 5 is 120 degrees. I see the 120 degrees in the same location as angle 5, and I know that corresponding angles are in fact congruent, so therefore angle 5 must be 120 degrees. All right, now let's find angle 8. Okay, angle 8. Now we could use one of our congruency problems and compare it to something over here. Or if you know what angle 5 is, hopefully see that angle 5 and angle 8 are going to be vertical angles. So like I said, many options. But I'm going with a different route here. I'm going alternate exterior. Okay, so just to show you guys, alternate exterior. So I'm looking at the 120 and angle 8 because they are alternate. They're on different sides of the transversal. And they're exterior because they're on the outside of the two parallel lines. And I know that alternate exterior angles are congruent. So therefore, angle 8 is 120 degrees. All right, example 2. Using properties of parallel lines. All right, so we're going to find the value of x, and we're going to name the theorem that we're using to discover this answer. Okay, so we're looking for the measurement of angle 4. Okay, and I also added another component here. This is itty bitty, I know. That's angle 3 is this x plus 5. So to figure out what angle 4 is, it seems, hopefully something stands out, that it is vertical here. 115 degrees is vertical to the 4, so I can easily establish then that angle 4 is 115 degrees, and I know that because of vertical angles. But that doesn't really help me figure out what x is. So let's see, what do we know about angle 4, which, let me write it in. We already said it's 115 degrees, that we can use. Which one of our new theorems can we use that we learned about that compares these two together? Now these two they're on the same side, so I know they're consecutive, and they're interior, they're inside, so same side, interior, consecutive interior. And what I know about consecutive interior angles are that they're supplementary, meaning that they add up to 180 degrees. So we can add these two together and make it equal to 180. So our second theorem that we're using is consecutive interior angles. Okay? And we're establishing that 115, because that's what angle 4 is, plus x plus 5 would have to equal 180 degrees. So we're going to solve here. Combine like terms. 115 plus 5 gives me 120 plus x equals 180. We have to subtract 120 to both sides. That cancels out. We get x by itself, which is what we want. 180 minus 120 leaves us with 60. So x is 60. All right, same type of problem. We're going to look for the measurement of angle 2. And we're also going to establish what is the measurement of angle 1. Now, angle 1 is going to be the easiest one to discover. Guys, remember, if you ever need to have a sheet of paper out and you can cover stuff up to help make it easier for you to see what's happening, then utilize that, okay? Because if I cover this up, I can easily see that angle 1 is a linear pair with the 136 degree. So if I know that they're a linear pair, I know that they add up to 180 degrees. So all I have to do to figure out angle 1 is take 180 and subtract it from 136, and I'm left with angle 1 equaling 44 degrees. All right, so 44 degrees is angle 1 there. Okay, now trying to figure out what relationship does that angle 1 have, which is the 44 degrees, so I'll fill that in. What relationship does that angle 1 have with this angle 2 that I'm looking for? Now, I notice they're on different sides of the transversal, so I automatically know that means they're alternate, and they're outside of the parallel lines, so that means they're exterior. So this is alternate exterior, and what we know about alternate exterior angles is that their measurements are, in fact, congruent. So if angle 1 is 44 degrees, then I know the measurement of angle 2 has to also be 44 degrees, but we got to solve for x, so my equation is going to be 7x plus 9 equals that 44 degrees. So let's solve here by subtracting 9 to both sides. You get 7x equals 35. 44 minus 9 is 35. And we're going to now divide both sides by 7. And we get a grand total of x equals 5. Why is that not moving? Sorry. X equals 5. All right, given the measurement of angle 3 at 68 degrees, and as I wrote it in already, angle 3 is 68 degrees, and the measurement of angle 8 is 2x plus 4, what is the value of x? Show all your work. All right, so figure out what relationship do these two have with one another. They're on the same side, and they are outside the parallel lines. So what theorem is that? Hopefully you're saying consecutive exterior angles, okay? Same side, exterior angles. And remember, consecutive, aka same side, means that they're supplementary, so they add up to 180 degrees. All right, so in order for us to figure out what the value of x is, we're going to take those two and we're going to add them and make them equal to 180 degrees. So 68 plus 2x plus 4 equals a grand total of 180. I'm going to combine my like terms here. So we get 2x, 68 plus 4 gives me 72. Supposed to be plus 9. Equals 180. All right. Now we're going to subtract 72 to both sides. And I'm going to rewrite the work over here. You get 2x equals 180 minus 72 leaves me with 108. And my last step is going to be to divide by 2. So we get a grand total for x to be 54 degrees. Not degrees, sorry. X is just 54. My bad. X is 54. Now, on your own, find the measurements based on knowing this of what angle 1 is, angle 2, angle 4, angle 5, angle 6, angle 7, and actually angle 8. And I'll help you out with that one because we just figured out what X is. So really, if I just plug it in, 2 times 54 plus 4, and I solve that, we discover that angle 8 is actually 112 degrees. All right, so I need you to find these other angles, all right, and be sure that you copy that down and write it down because I will be looking for it. All right, let's look at a real life problem. Okay, so when sunlight enters a drop of rain, different colors of light leave the drop at different angles. Okay, this process is what creates a beautiful rainbow. Okay, so for violet light, measurement of angle 2 equals 40 degrees. What is then the measurement of angle 1, and how do you know? So they're telling us that measurement of angle 2 is 40 degrees. All right. Now, they did a nice thing. They drew these lines here. Okay. And hopefully you recall these symbols, which would tell us then or imply that these two lines are in fact parallel. Now, if you have to, you can always feel free and extend them so you can really see the lines here. All right. So if those are my two parallel lines, then that would make this line here my transversal. All right, so kind of similar problem as before. Now, what we're asking ourselves here in order to figure out what angle 1 is, what is this person's vision, what's their sight here, what degree is that, is what relationship do these two angles have? What does angle 2 have in relationship with angle 1? Now, I know that they're both located inside of my parallel lines, okay? And I also notice they're on different sides of the transversal. So different sides of the transversal tells me they're alternate. If they're located inside of the parallel lines, that tells me they're interior. So there's our answer. They're alternate interior angles. Okay. And what do we know about alternate interior angles and their measurements? Their measurements are deemed to be congruent. So this angle is congruent with this angle. Angle 2 is congruent. The measurement of angle 2 is congruent to the measurement of angle 1. So therefore, if angle 2 is 40 degrees, then we would know that angle 1 has to also be 40 degrees. All right, a balloonist sees a car at 37 degree angle of depression. Okay, so a balloonist is obviously in this hot air balloon up here at the top, and they're looking down. That's why it's an angle of depression, because they're looking down to this car, which is creating a 37 degree angle. Okay, so basically, angle 1 here is the angle that they told us, which is the 37 degrees. All right. What is the measurement of angle 2? So again, let's see if we have any parallel lines and transversals here. So I'm going to extend this line. I'm going to extend this line where the road is. And I do note that I have this symbol here, which tells me that these two lines are parallel. So we have our parallel lines. And I also do know that there's a line from the hot air balloon to the vehicle, and that would create our transversal. So what relationship then do these two angles have? Angle 1 and angle 2, they're located inside, okay, and they're on different sides of the transversal. So that would lead us to believe that these are alternate interior angles. And alternate interior angles are congruent, so therefore the measurement of angle 1 is congruent to the measurement of angle 2. So angle 2 has to be 37 degrees. All right, so here we're going to find the value of x, and we're going to show all our work. So given this information right here, we are going to use it to help us figure out what x is. Now, we got to figure out what we have. So this is 3x, and then this one here is 2x plus 20. All right, now we're going to have to use some inference information because based on where these are located, they're located on different sides of the transversal, but one is inside of the parallel lines and the other one's outside the parallel lines, and we actually don't have any congruency theorems for that situation. So we're going to have to use something else to help us come up with our answer. Now, I know that where the 2x plus 20 is, it would be vertical to this angle here. All right? Hope you guys are seeing what I'm saying. So this angle, where the 2x plus 20 is going to be congruent to this angle here because it's vertical to it. All right? So I'm basically going to rewrite the 2x plus 20 to go for this angle here. All right? Because if I do that, I have created them now. Both of these angles are now on the same side of the transversal. Okay, and they're both located on the outside. So this is a consecutive exterior problem, exterior angles. Okay, and if they're consecutive exterior angles, then their measurement adds up to 180 degrees because they're supplementary. Now knowing that, we can actually approach this problem and answer it. So we're going to take those two angles and add them. 3x plus 2x plus 20. And we're going to make that equal to 180 degrees because they're supplementary. Combine like terms first. 5x plus 20 equals 180. We're going to subtract 20 to both sides. We get 5x equals 160. Last step is to divide. And we are dividing by the number 5. And when we do that, we get a grand total of x equals 32. X equals 32. All right, this next part B, you're going to be using this figure down here to figure out what the value of x is. Okay, so you're going to do this one on your own. Please also write down which theorem you're using to prove it. Okay. All right, again, same situation, find the value of x and y, show our work, and as always, I always like to state what theorem we're using, okay? Helps back everything up. So, based on what we have here, let's see, I think I'm going to start off with these two values. I'm told that this is 48 degrees, and this is y degrees. So, what relationship then do these have right here? Let's see, they're inside parallel lines. Okay, and they're on the same side of the transversal. So that would make them same side. So that means they're consecutive. Okay, and if they're consecutive and they're inside the parallel lines, so this is consecutive interior angles. And consecutive interior angles are supplementary. Okay, they add up to 180. So that's kind of easy. All we have to do to figure out y is well, let me write it out mathematically. 48 plus y equals 180. All you do is subtract 48 from 180, and we know that y is a grand total of 132 degrees. Okay, and I can actually state that y is actually 132 degrees. Now, curious, what relationship does y have, y degrees here, which is 132, have with the one that's right next to it, the 5x minus 17? Hopefully you see they create a straight line. They share a common side. They're side by side, meaning they're adjacent. So this looks like a linear pair. And if they are a linear pair, we know that linear pairs are supplementary. So we can then state that we have 5x minus 17 plus the y degrees, which is 132, equals 180. Combine like terms. So if we combine that negative 17 plus 132, we get, bring down 5x, we get positive 115 equals 180. Okay, we're going to subtract 115 from both sides because we're solving for x. And we get 5x equals 180 minus 115 is 65. And our last step is to divide that by 5 to get x. And we get that x equals 13. So x is 13. Y was 132. Now, you now are going to attempt part B using this information here. All right. Good stuff. Good luck.